So let's take a look at this problem. It's a substitution problem. So I need to integrate this expression. And the way I see it is I see a function, the x to the 3/2 plus 7, inside the cosine function. So it's a function in a function. That's this piece here. And if I think about what's the derivative of the inside function, the derivative of the inside function is 3/2 x to the 1/2. So a multiple of the derivative of the inside function is multiplied on the outside. So that's why I think substitution is going to work. Even if, well, substitution is always a thing that you think about when you see a function inside a function. So the cosine is the outside function. So our substitution would be, I would let u equal to the inside function. Substitution is a two-part process, so I differentiate that, du dx. I use the du dx instead of the u prime because I want to solve this expression for dx equals. So dx equals du divided by this derivative. Now, let's replace. We're going to put u in for what the inside function is, and I'm going to replace dx with this expression with du in it. Since I'm changing everything to u's, I want to switch everything, even the dx, into a version of du. So that's what I've done here. So I've replaced the inside function with u and the dx with the du divided by. Now, the x to the 1/2 on the top and the x to the 1/2 on the bottom cancel. And this divided by 3/2, I just inverted and multiplied. It's a constant, so it goes outside. Now I'm just asked to integrate only cosine of u. So what differentiates to be cosine u? Sine u. Now I'm done my integration. I can substitute back in what u is. Don't forget a plus c, and I'm done. That's how I wanted that first question to be done. But let's take a look at another question just for funsies. And what I'm going to do is I'm just going to change the outside function. So now it's a function, the same function, that x to the 3/2 plus 7, inside the sec squared function. Function in a function. But the substitution is going to be exactly the same. So all of this line is exactly the same. And when I swap those pieces out, I'm going to get, well, everything, this will be the same. Remember, the only thing I changed from the first example to the second example is instead of cosine, it's sec squared. When I do my canceling, though, and invert and multiply the 2/3, then I'm integrating 2/3, well, the 2/3 is a constant, same as before it comes out, sec squared u. du. Now, what do you differentiate to get sec squared? Tan. So I'm going to have my 2/3, that's just a constant, tan u, and now I'm done with the integration, so I can replace back what u is, and so what was u? U was still the same inside function. And don't forget a plus c, and I'm done. So the difference between these two examples is I just changed the outside function. We could have changed the inside function as well. Let's do one more example. So to do one more example, I need to be integrating, and in this case I'm going to put a function in a function. But, so I still have a function in a function. Now, there isn't on the outside a multiple of a function on the inside. Let's do that. Let's put an x here. So the function x plus 2 is inside the to the 3/2 function. It's still a function and a function. This x on the outside, though, isn't a derivative, isn't a multiple of the derivative. But I'm still going to do the same setup. I'm going to let u equal to the inside function. I'm going to differentiate du dx. So du dx is equal to 1. Now that means that du is equal to dx. So I'm using those to switch everything over. So it's going to be integrate x u to the 3/2. And instead of dx is equal to du, so now I'm trying to switch everything over to u's. Notice what didn't happen. In these first two examples, when I did the substitution, everything, all the x's canceled out. And here I still have an x. I need to get rid of that x. I need to turn it into something with u's. I'm integrating everything with respect to u. So if u is equal to x plus 2, then x must equal to u minus 2. Nice. Now everything's in terms of u, du. Can I integrate that? Yeah, let's multiply this out. So that's going to be integrate u to the 1 times u to the 3/2, add exponent. That's going to be u to the power of 5/2. That I can integrate. Minus 2 u to the power of 3/2. So it's just a couple of add one to the exponent, divide by what's up top. So it's going to be add one to the exponent, so this becomes a 7/2. I want to divide by 7/2. Of course, dividing by 7/2 is the same thing as multiplying by 2/7, invert and multiply. I'm going to add one to this exponent, so it becomes a 5/2. Instead of dividing by 5/2, I'm going to multiply by 2/5. So this becomes a 2/5 times 2, that's 4/5. Now I'm done with my integration. I can put back in for what u is. U is equal to x plus 2. So everywhere there's a u, I'm going to put an x plus 2. Inside here goes an x plus 2. I'm not yet done. Got to put a plus c, and now I'm done. So there's some substitutions. So this one is sort of a different setup, the last example, because the x's didn't cancel. But take a look at these two examples and see the similarities in them.